All right, here we go, 6-7. 6-7. Now we're going to talk about inverse functions today. Inverse functions. You already feel bad about it? Maybe I've scared you too much. Maybe this isn't as bad as I've said it is. All right, inverse functions. Okay, first of all, let's talk about how to find the inverse of something, okay? So we're going to have a function, and then we're going to try and find its inverse. And here's what you do. It's pretty easy. All you're going to do is switch x and y. Okay? So all the x's become the y values, and all the y values become the x values. Okay? And with that, when you switch x and y, what happens is their domain and range switch also. Because let's remember that the domain are the x values. Okay, all real numbers or all real numbers, not 3 or whatever, greater than or equal to 0. And then the range are the y values. And so those will get switched with it. Okay, so you switch x and y, and then you switch their domain and range also. Okay, now let's talk about functions real quick. We had a test on functions to see if it was a function. Do you remember what that test was called? Something. Vertical line test. Yes, the VLT. Sounded like a delicious sandwich, but it's not. It's the veal, lettuce, and tomato. It's the vertical line test. And the vertical line test tells you whether or not something, vertical line test, tells you whether or not something is a function or not. Okay? So we did the vertical line test on all kinds of things, and we said yes or no, it was a function. And it was pretty easy, especially if you have the graph. Now today we're going to learn something called the HLT. The HLT, what do you think that is? Yes. Ham. Yep. Ham, lettuce, and tomato. It's the horizontal line test. And the horizontal line test is also done on the original function. Okay? It's on the original function. To determine if the inverse is a function. Okay, to see if the inverse is a function. So we have the vertical line test to test if itself is a function, and then we have the horizontal line test to see if its inverse will be a function. So let me go ahead and I'll give you some picture examples of this. Yeah?
Can't you just look at the x's and see if the same thing goes different things?
Sure. Like the x's can't repeat.
Like if 2 3's go, like one goes to 4 and one
right.
goes to 5.
Yes, that would be good if you had like an XY chart of things, but if we have like a picture or a function, like an equation, then it's a little bit harder to do. But yeah, you're right. If you had like x and y's, you would totally do that. So let's go ahead and do number 1. And the question is going to be, is the inverse a function? Now, we don't know how to find the inverse yet. I'm going to teach you that in a minute. But you don't need the inverse to see if the inverse is a function. You just need the regular function itself. So let's go ahead, do letter A. And let's have, I'll just give you a picture. Okay? Here's a graph. I'm going to tell you what the graph is. There it is. Okay, we recognize that graph. We've seen it before. We've graphed it. We took a whole chapter just studying these things. Do you remember what it was called? That's a quadratic, and then its graph is called A, starts with a P. Parabola, yeah. Now, are parabolas, are they functions? Yes. They pass the vertical line test. But that's not the question I'm asking. The question I'm asking is its inverse a function? So we have to do the other test, the horizontal line test. The horizontal line test, in this case, it fails because it hit 2 points. So is the inverse of a parabola a function? The answer is no. Just like that. When I move, you move. All right, letter B. Here we go. How about y equals 3x plus 1? Now, I didn't give you a picture this time, but you have a mind, and you know how to graph that in your mind, right?
Can you show me?
Okay, I'll show you my mind right now. In my mind, I'm thinking 3x plus 1 is a line, look, something like that, right? I don't even really care. I don't even know if I graphed it that correctly. I did because, you know, I went to 1 and then I went up 3 and over 1. I graphed it really, really good. But if you don't, that's okay. If it's off a little bit, you know, you can still know that's a line. Now, does a line have an inverse function? Horizontal line test. Yes, it does. Okay? So I'm not going to, let you not graph this in your head. Like this next one, letter C. How about y equals the absolute value of x plus 3 minus 4? Okay, you knew that already because you know from previous chapters ago, you know what an absolute value looks like. You might not remember that we shift 3 to the left and 4 down, okay? But you know it's a V shape, right? You know that because you have prior knowledge. And so if we do the horizontal line test on that, oh no, it hits twice, so that would be a no. Its inverse is not a function. Okay? You're pretty good? Yeah. You know a lot of graphs now, don't you? Aren't you pretty excited about that? No, great. Okay, that's neat. Let's go ahead now and let's find the inverse of a few things, okay? So here we go. Number 2. We're going to start off a little easy. We'll make our way to super hard. I know. So we're going to do a couple of things. We're going to find the inverse, and we are going to do your favorite thing of all time, graph. We're going to graph both the original function and the inverse. We're going to graph them both, okay? So we're going to find the inverse first and then graph. So here we go. Number 1, or letter A. We're at number 2. I'm going to give you a table of values, x and y. And here are some points. We have -1, 1, 0, 2, 1, 3, and 1, 4. All right, so right away, if you remember, the x values can't repeat, so you know this is not a function. This can't be a function. If 1 went into your function machine, it comes out at 3, and then 1's like, I'm going to try that again, and come out at 4, you can't do that. It's not a function, okay? All right, so let's go ahead, and we're going to find the inverse. To find the inverse, all you do is you take your x and y's, and what do? We wrote it down. You switch them. And so all these x's, -1, 0, 1, 1, are going to become the y's, -1, 0, 1, 1. And all the y's are going to become the x's, 1, 2, 3, 4. That's it. It's that easy. Now let's go ahead and graph both of them. Okay? So here we go. These are all points. It's just 4 points. So I'm going to go 1, 2, 3, 4 in each direction. One, 2, 3, 4. Okay. So I'm going to graph them in different colors so that you see which one's which. I'm going to graph my original in blue. So we'll go -1, 1. Put a dot there. We'll go 0, 2. So we're just plotting 4 points. And then we'll go 1, 3, and 1, 4. Now do you see right away that that can't be a function? See the vertical line test right here? It fails. It has to pass in all the places. It fails right there. Now, the other one, the inverse of that, is I'm going to graph in red. So I have 1, -1. Then I have 2, 0, 3, 1, and 4, 1. Oh, look at that. That's interesting. Seems like there's a relationship between those points, right? And there is. All inverses, and here's the key today, all inverses are going to be a reflection over this diagonal. This diagonal is the line where y equals x. Okay? So if you look at, say, this one, this point, across from this point is that one, across from that line, across from that line, and across from that line, they're all a reflection over each other. Yeah?
Is that the only way, like the only line you can reflect over?
Yep. That's it. All inverses reflect over that line, the diagonal. Okay? Yes. Isn't that fun? No. All right. Should we move on? That's the easiest one. Let's go. All right. Now let's do a line. Are you ready for a line? Yes, you are.
Yeah.
Okay. So those were just points on a graph. You just switch x and y. You graph them. Now let's do y equals 3x plus 2. Okay. Our first step is to find the inverse of this. Okay? So what we're going to do is we're going to switch x and y. Like literally take x and y and switch places. So we get x equals 3y plus 2. All right, and now we're going to solve for y. We did this first semester solving for a variable. First thing you want to do is subtract 2 to the other side. X minus 2 equals 3y. And then divide everybody by 3. So I get y equals x minus 2 divided by 3. So that's the inverse. Okay, that's kind of ugly, right? All right. It's really, if you were to separate this, it's really the line 1/3 x minus 2/3. See, both things are divided by 3. Now, to graph this, though, I'm going to show you a nice, easy way to graph this. Here we go. Okay, first things first, we are going to graph our original graph, y equals 3x plus 2. I hope that all of you can do that. I hope so. Let me go ahead and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, I think that should be enough. Okay. So let's graph the first one. The first one, we're going to go up to 2 on the y-axis. Do you remember graphing this? You go to the y-intercept, and then you count slope. And our slope on this one is rise 3 and run 1. So 1, 2, 3, and run 1. And then draw a nice, ew, that's really bad. A nice straight line through that. Terrible. Okay, hopefully yours is better than mine. Now, to graph this would be super ugly to graph. I don't want to graph that. You know what I'm going to do? I'll tell you. I'm going to take these 2 points that I have on here, and I'm going to switch them. Switch the x and y. So this point that I have on my graph is the point 0, 2. Do you all agree? And this point is the point 1, 5. And I know that my inverse is going to have the point 2, 0 on it. And what else? 5, 1. Yes. So I can graph those 2 points. So I have 2, 0 and 5, 1. And then I'm going to draw a nice straight line through those. Oh, that's better. And there we go. And then if you draw it correctly, it should be a reflection. Oh, that's so good. My drawing skills are so good today. Usually I stink at this, but yeah, today, not so much. See? And you go like that. And you flip over, and there it is. Yeah. In the middle of notes, you can go for a tardy or wait till the end. Yeah, it's up to you. You got choices. All right, let's go ahead and do the next one. Oh, by the way, let me talk about domain and range real quick on these. It's a slanted line. Domain's going to be all real numbers. The range is all real numbers. So when I find the domain and range of the inverse, it's pretty easy. All I do is switch these. Okay, all real numbers, all real numbers. Lines are super basic, okay? They're not very fun. It's always all real numbers, all real numbers. The next one I'm going to do, not so much. Here we go. See, it gets harder every single time. By the way, if we have a function called f of x, then this is the notation for its inverse. We call that f inverse of x. Then f, this is the inverse. It's just like a new notation. I don't use it a lot, but that's what it looks like. Okay? All right, here we go. Letter C. So we've done points, we've done a line. Let's do a parabola. Bless you. All right, suppose I have f of x equals x squared plus 3. I'm going to do both things. I'm going to find the inverse, and then I'm going to graph it, and then we're also going to talk about its domain and range because we need to. Okay, so here we go. First of all, we need to switch x and y. And some people are looking at that like, there is no y. How do you switch x and y? Well, f of x is the same thing as y. And so we're going to go x equals y squared plus 3. Okay? So x goes over here. This is like a y. Y goes over there. And now we have to solve for y. Our first step, subtract 3. Okay? Now we're solving for y, and y is squared. So what do we need to do? Square root. And when we take the square root of an equation, we need plus and minus square root. And so that would be the inverse. Don't forget the plus and minus. It's really important. All right, so there's the inverse, and I don't think that's the hard part about today. I think it's the graph and the domain and range, which is the hard part. So let's go ahead and graph these things. Now, do you remember how to graph a parabola? How about this parabola? X squared plus 3. This is just a regular parabola of x squared, and it's shifted what? 3 up. Remember? Remember, shifting on the inside is left and right, and then shifting on the outside is up or down. So this is just 1, 2, 3. And then it's your basic parabola. It's just up 1 and over 1. Should have done it in blue. Here we go. And then you draw a nice little U shape through that. There we go. And there we go. And do you know how to graph on your calculator? I mean, we spent a lot of time graphing these. If you went to your calculator and you could graph y equals, what is it? X squared plus 3. X squared plus 3. And then you can get a pretty decent graph. If you want to get some actual values, you could go to the table. Oops, second table. And that'll give you some values that you can plot. Okay? That's okay. It's not cheating. We already did these by hand. All right, so there we go. Now, to graph this, though, do you know how to graph that? No, we don't really know how to graph that. So let's take these 3 points and let's switch them. Okay? So this right here is the point 0, 3. I also have the point 1, 4 and negative 1, 4. And let's find 3 new points that I can plot to make my new graph. So my new plot for my inverse will be to switch all the x and y's. I mean, it's really that simple. Doesn't feel that simple. I know this is a hard lesson, but it's not too bad. And then we'll graph 1, 2, 3, 4. We'll graph 3, 0 right here. We'll graph 4, 1. And we'll graph 4, negative 1. And so what we get, this right here is the top half of that square root, and the negative is the bottom half of the square root. And that's what you get. And if you were to, look at your paper and draw that diagonal, you should be able to see a reflection over that diagonal every time. Let me show you on your calculator real quick. If you were to graph the square root of x minus 3, square root x minus 3, and we hit graph, it's only going to do the top half. See, when you're in this mode, y equals, you're in function mode. Is a sideways parabola a function? No, it's not a function. So if you were going to graph both parts of it, you'd have to really graph 2 things. And then x minus 3, and then that'll give you the second half of it. See? Now, it doesn't really look like it's a reflection, but if I hit zoom square, then it will give me a square window instead of a rectangular window, and it'll look a little bit better. Hello? Does that look better? Sort of, not really. I don't know. It didn't look much better at all, did it? I'm hitting enter like 5 times. Okay. All right, so you're okay so far? We got another one. Oh, domain and range. Don't let me forget that. How dare you? All right, let's talk about the blue. I know, I'm sorry. Domain and range. Okay, it's a parabola. We did domain and range back in chapter 4. I mean, it's a long time ago. I know, it was before Christmas and everything. So what is the domain of this parabola? All reals. Remember, I don't know, some of you were in my class. I said everyone was going to get that right.
So for the homework, do we need to draw the graphs?
If it says to, you do.
Okay.
Yeah, I'm just doing them all so that we have them. All right, what is the range on this? The range are the y values. What y value does this start at and go up from? Greater than or equal to 3. Okay, good. Now you remember how to do that. Now over here, we're going to switch them. The domain and the range. Okay. Domain is x is greater than or equal to 3, because it's switched, and then the range is all real numbers. See how they switched? The x and y switch, and so this is y is greater than or equal to 3 becomes x is greater than or equal to 3, and the domain is all real numbers becomes the range, all real numbers. All right, last one of these. letter D. Okay, now if you tune me out, which I know some of you have, this one is going to be the hardest one. So here we go. Y equals the square root of x plus 1. Okay, woo! You ready? We're going to do both things. We're going to find the inverse, and we're going to graph and domain and range. So switch x and y. It's not too bad. Y plus 1. And then go ahead and square both sides so that x squared equals y plus 1. And then solve for y by subtracting 1 over. So we get x squared minus 1. So there is the inverse. Okay? And now we're going to graph them both. All right. So let's talk about this first graph. Hello. You're being recorded, so be careful what you say. Okay. All right, so here we go. Y equals square root of x plus 1. I just got a raise of $500. Thank you. Okay, so no. Not a chance. All right, 1, 2, 3, 4. 1, 2. I should, though. All right, here we go. 1, 2, 3, 4. All right. It's a thankless job. Although most of you say thank you on your way out. I really appreciate that. Oh, you're welcome. Okay, here we go. Now, do you know how to graph a square root? No, you don't. You know why? Because we skipped that lesson. So, yeah, you're welcome. So go ahead and go to your calculator, and you can graph a square root very easily. I already did, remember? That last one. Yeah, here's how you graph a square root. You go square root of x plus 1. And you hit graph. Ooh, there it is. That's it. That's what a square root graph looks like, okay? Now, where does my x start at? Can you see where it starts at? I wish I could zoom in on this, don't you? Do you ever do that? Like -1. -1, yes. That's exactly where we start at. Okay, so we start here at -1. Now, if you want some specific points, you can go over to the table. Have you ever used the table feature? It's really nice. Second graph is table. And you go over to the table, look at all those errors. At -1, y is 0. At 0, y is 1. And then here's another good point, 3, 2. Okay? So I've got this.
Wait.
Yeah?
Can you go there again?
Sure. Sure. Second.
Oh, it does that for you?
Yes.
Oh.
It makes a t-chart for you, x and y. So I have 0, 1. -1, 0, and 3, 2. Those are really good points. See all those other decimals? Do I want those? No. Okay, so here we go. This is going to be the graph of my inverse. Now, I'm going to take those 3 points that are really nice, -1, 0, 0, 1, and what was that? 3, 2. And I'm going to switch them all. Okay? We switch all of these. So this is 0, -1. 1, 0, and 2, 3. It's nice to write them down too so that you see what they are and then you can plot them. So I get 0, -1 right here. 1, 0 is here. And then 2, 3 is up here. Oh, and so I get this. Now, let me ask you, does y equal x squared minus 1 equal this? Almost, right? If I went to my calculator and I were to graph x squared minus 1, it will give me a parabola on both sides. But I don't want that other side. Because remember, this has to be a reflection over this diagonal here. Okay? And so when you say this, you have to say what the domain is. So let's talk about domain and range real quick. Domain and range, and then domain and range. Okay. Domain and range have always been tough subjects, so let's talk about this blue one. See, domain are going to be the x values, and where did we say the x's started at? What was our lowest x value that we could have? It was -1, right? Okay, so that means that x has to be greater than or equal to -1. Take a look at our equation up here. Can I plug in anything less than -1? No, it's going to give me a negative value. Now, what's the range? Where do my y's start at? The y's started out on the table. You could even see on the table 0 and more. Okay? Y would be greater than or equal to 0. Now, for the domain and range of this, once you have this, guys, this blue part, this one's easy now. You just switch them. So what would the domain be?
0.
X is now greater than or equal to 0. And the range would be y is greater than or equal to -1. These right here, they get switched. But you still have to say domain is x and range is y. So, and they just get switched. And so when I say that the domain is greater than or equal to 0, that means it's only this one side of the whole parabola. It's not the whole thing. That's the hardest part of today, right there.
For real?
Yeah? Was it hard? Not that bad?
No, right?
Oh.
One that I'm gonna do is
But I feel like in the homework